Welcome back. This is the 7th video for Chapter 7, Arrays. And in this video we're going to look at sorting arrays in particular. So our focus is going to be on sorting, and we're going to use what's called an insertion sort algorithm to do that. So remember that our problem is, given an array, we're going to reorder the elements of that array so that they're in non-descending order. We're going to use that insertion sort algorithm, and that works a lot like you would sort playing cards as they're dealt to you when you're playing poker or any other type of card game. So let's take a look at a card example real quick. Okay, so let's think about having a deck of cards here. What we're going to do is deal out several cards into a hand and watch how they're sorted as we go. So our first card that comes out is a 2, and when we put that into our hand, obviously it's sorted, so it goes all the way to the left. And that would be true even if it was an ace or a king, because it's the only card in our hand at that point. Now my next card is a 7, so that will be placed in my hand at the end, because 7 is greater than 2. My next card is an ace, and so this will also go at the end of the hand because an ace is greater than either a 7 or a 2. Now what about a 3? Well, think about sort of doing it step by step. We'd compare the 3 to the ace. Well, it's smaller than that, so move it in here. Compare it to the 7, smaller than that, so move it again, and it'll end up between the 3 and the 7. Another ace. All right, so now this will go at the end, and we'll have some sorting going on between suits. And so in this case, we'll say that clubs go before diamonds, so the ace will be put there. A 4, so we would start at the end. It's less than an ace, less than an ace, less than 7, not less than a 3, so it goes between the 3 and the 7. A queen, less than ace, not less than 7, so it goes there. And a 3, so now my 3 of hearts would be in front of the 3 of clubs, but it's less than an ace, less than an ace, less than queen, less than 7, less than 4, less than this 3, and it goes there. Let's do one more card. Another 3. Okay, in this case, the 3 of diamonds we'll say is greater than the 3 of clubs, so less than ace, less than ace, less than queen, less than 7, less than 4, but greater than 3 of clubs, so it goes there. Okay? So our insertion sort is going to work a lot like that. And now that we've looked at the cards, let's take a look at our algorithm. So you'll notice that this algorithm has nested loops. The outer loop, the 4J loop, basically picks an element, and then we're going to use the inner loop, the while loop, to shuffle that element to the left until it ends up in the correct position. So in our loops here, the J variable, that's the one that's picking the card, if you will, or the element that we're shuffling into the correct position, while the I variable and our temp variable are used for that shuffling process. Okay, so again, the idea is to look at an element starting with element 1, the second element of the array, shuffle it to the left until we find its correct position, and then move on to the next element, J. So let's begin with our example. This is our initial array. My value J is going to start here at spot 1 in the array. We're going to shuffle it leftward until we find its correct location. Notice that everything to the left of spot J is assumed to be sorted already, right? And if you think about it, an element, or an array rather, of only one element is always in sorted order. So we're good to go there. Okay, so we're going to go ahead and check to see if the 22 and the 68 need to be exchanged. And yes, they do. So we make that swap, and now The green elements, the green highlights, show me the portion of the array that is sorted. Now my value of j moves up by 1 to here. Okay, and what we're going to do is shuffle that element to the left until it's in its correct position. Remember, everything from here on this direction is already assumed to be sorted. So as soon as I find an element less than 90, I'll know to stop shuffling. Well, that happens pretty quickly, doesn't it? The 68 is less than 90, so the 90 was already in its correct position. Now we move up. My value j indicates that the 77 is the value that I'm going to be shuffling. And what I have to do is start comparing it to neighbors so that I can move it leftward until I find its correct location. Okay, so the 77 and the 90 get switched. And now I'm going to compare the 77 to 68 to see if the 68 is less. And it is. And so now the first 4 elements of the array, everything from here on over, is sorted. Next, we're going to look at 39. And again, we'll start by comparing it with its neighbor. Swap it. Compare to its neighbor. Swap it. Compare to its neighbor. Swap it. And lastly, for the 39, compare to its neighbor. No swap is required. And now, so everything from here to the left is sorted. Do you see what's going to happen next with my 1? Yep, you guessed it. This is going to be a long one because I have to compare it to this neighbor, this neighbor. That's this comparison here. Make that swap. Compare it to this neighbor, swap. Compare to this neighbor, swap. Compare to this neighbor, swap. And now I'm done. I can't go any further to the left because I'm out of array, but now everything from here to the left is sorted. Now repeat the process again. Compare, swap, compare, swap, compare, no swap, sorted. Compare, swap, compare, swap, compare, swap, compare, exchange, because I'm getting tired of saying swap, compare, exchange, compare, exchange, compare, and no swap necessary, so this much is sorted. Tell you what, for these next few, you narrate it as you watch.
Every day I'm shuffling.
And now everything but the last element is in the correct order. Okay? Compare, swap, compare, swap, compare, swap, compare, swap, compare, no swap, and hooray, everything is sorted. Okay. So one thing that's really nice to think about with the insertion sort is that if I happen to give the insertion sort an array that's already in order, it will be very quick in verifying that it doesn't have to do anything. So that's a good feature of insertion sort, is that if you're sorting something that's almost sorted already, insertion sort is very fast. All right. Now, a more fully developed example that uses insertion sort will be covered in the sorted lines example video. And so in that situation, what we do is we take a screen that has a series of different lines that have different heights and different colors, and those represent the values in an array. And then we apply an insertion sort process and redraw the values based on their heights, and we end up with a different arrangement and sort of a pretty color gradient as it goes from blue to red.